hosted by the Department of Mechanical Engineering, MITE, Karnataka. I am Anudeep Raupi, Assistant Professor in the Department of Mechanical Engineering, will be coordinating this session. To begin with, I extend a warm welcome to Dr. K.V. Gangadharan on behalf of Department, Institution, Management, and all the participants. It is my immense pleasure to introduce Dr. K.V. Gangadharan to all participants. Dr. K.V. Gangadharan is a professor in mechanical engineering and head of the Center of System Design and President, Institute Innovation Council, National Institute of Technology, Karnataka, Suratkal. He has earned his PhD from IIT Madras in the year of 2001 in the area of railroad vehicle dynamics, ME from NIT Trichy in the year 1992, BTech in Mechanical Engineering from Calicut University in the year 1989. His areas of research are system design, vibration and its control, smart material and its application, structural health monitoring, and product design. He is also actively engaged in creating learning materials for experimental learning of basic concepts in engineering. He has teaching and research experience of 27 years and industrial experience of 1 year. He is actively engaged in industrial consultancy and sponsored research projects and has more than 120 research publications in his credit. He has filed 7 patents, 4 in the area of medical devices and 3 in smart material application. He has an active HAM amateur radio with a call sign of VU2TAO in charge of the amateur radio facility at NITK Suratkal. We are indeed delighted to have him here with us today. So again, welcome you, sir. With this brief introduction, so I hand over the session to the professor. Hello, sir.
Thank you, Anudeep and the team from MITE. I'm so happy that I have a session, the pre-noon session, so that let us see how we will take this subject in a way that gives you a feel of what is that I would like to cover. Let me just see whether I can show you the PPT first. I'll just get my PPT running so that we can straight away start with presentation.
Hello, sir. Your PPT is not visible. Okay, now it is visible, sir.
Yeah, okay. Because I wanted the presentation to come like this. That's it. Okay. Very pleasant good morning and welcome on behalf of National Institute of Technology, Karnataka, Suratkal. What best way to start a presentation on sustainable development, then starting from the sea and coming towards the land. And I'm sure I'm not able to invite you to the institute now, so you can have a virtual tour at vtour.nitk.ac.in in the lecture time. So we had been doing a lot of things on the aerial domain, and that made us to look at even the solar farm in a bit different way. So I'm going to talk about that, and the reason for it and the story behind it is what we are going to look at today. So I'm sure that you have been enjoying the emerging trends in sustainable technology. And today I have been given the topic on fault identification in solar farms. So let us see how we will be able to look at solar farms and its fault identification. This is a very specific topic, so I'm not sure how many of you are quite familiar. So I'll try looking at it from slightly different perspective so that you get the basics at least clear in the presentation. So as introduced, I'm Gangadharan KV, and this is a place where I work, and we believe work is worship. Look at the farm which I have. It is not far away from all of you. It is in Mangalore. It is one of the consultancy work which we have taken up. Okay, and many places I may not be revealing the identity of the organization because of the non-disclosure agreement we have with them. But obviously, some of these things you should be able to make out from the way in which it is portrayed. And there itself, we had much deeper look at all this in this way. And something which I can reveal is about NITK, and we do have 1 megawatt power generation on solar, and almost all the rooftops of our buildings are already occupied with solar. So today we are looking at fault identification in solar farm. Okay, so you have already heard almost 4.5 days, and you have been here and you heard 4.5 days about sustainable development and technology for sustainable development. Are you just feeling that you have seen sustainable development, you touched and felt, and at the end, the story of 6 blind and the elephant comes to your mind? If that is the case, nothing to worry. That's what it is supposed to be. So all of us will come and talk about one topic, and you're supposed to just look at all this together as an FTP. So I'm sure that at the end, each one of us might have delivered one part of it, and you are the person, the learner is the person who is going to look at it in holistically. So let us just have a quick activity. What did they find? So I would like you to chat in the chat box and just type in, compare the teaching learning with the story of 6 blind and an elephant. Just give few things in the chat box. I'm seeing the neighboring next computer to see the chat box because my PPT is on. My screen will be full with the PPT. So I'm just returning and looking at the next monitor to make sure that I'm seeing your chat. Yeah, I need you to look at. I know there are 40 participants, including me. That is 2 minus 38 because I have logged in 2. I'm looking at typing the chat, type in the chat, wherein you say the FTP for 4.5 days, compare it with the 6 blind and an elephant. And how do you compare teaching learning with the story of 6 blind and an elephant? It's not a technical question. So I'm waiting for your chat to continue the session. I hope I'm audible.
Yes, sir, you are audible.
Yeah. So I'll wait until somebody gives me a few chat. Otherwise, it will be waste of my time spending online. Those who have not heard, I'm just going back. This is what I said. All are here for the FTP. All of you have touched and felt the things. At the end, all of us put together might have covered the entire FTP. And now I ask, compare this teaching learning with story of 6 blind and elephant. Okay. Sumati K has written it is incompleteness of knowledge. Yes. Go ahead. Now we have only very limited people, so I expect you to type in something. Lack of practical knowledge. Okay. Anudeep Rao written it as lack of practical knowledge. Dr. Lokesh has written, each person think in his own way based on imaginations and what they have. Okay. And the responses looks to be very low, and the number of people available are less. I was expecting quite few to listen. And if I don't see many of these things happening, I may just finish it as my Pushpanjali. That means putting flower to the bimba. May not go deeper into the sessions. Okay. So after forcing, there are 3-4 people who have responded. Good. Good to see that at least each one of you are looking at it. This is true that FTP is conducted in a classroom or an online environment, but what we need to experience is the wild, because we are not really touching and feeling the wild. So the situation is going to be entirely different when you get into the real field. So what we are going to discuss today, a few things which we are going to discuss today is what we experienced. We went out for consultancy on solar farms. Okay, so let us just dive into the solar farms and see whether we are able to get few things. So what happened is, it is that there is obviously a story behind each of these things. We have been working on different things and at Center for System Design, which is a transdisciplinary research center. So we also happen to have few activity to moving around inspection. Okay, so when it comes to inspection, we were forced to look at solar panels, which we did not know what it is. So then we started looking at what is solar panel, how is it connected, what is a system called off-grid system, what is on-grid system or net metering, and how these connections are. These basics were quite essential for us to understand what kind of fault can occur and how do we look at it, and what way we can find the fault and detect the fault, and that too in a very simpler way. So just have a look at the kind of diagrams which I have shown. We'll take it further. So we had a set of solar panel which was giving a DC voltage output, and it was connected to a solar inverter. Either the solar inverter can be grid connected, directly connected to the grid, or it can be just given to the home, or it can also be given as something which is with a storage system, a battery backup. Then it can again connect back to through an inverter, AC DC inverter, to your home appliances. So let us just look at the components, because this is required to understand where we have to look at the fault. One is obviously the solar panels, then comes the inverter, and then the battery system if it is with the storage. Okay, so we'll just see how we are looking at the fault. Before we get into the fault, we need to know what are we looking at. The solar panel, how it is constructed, and what are the layers, and if I'm inspecting it, I should know which layer is giving me the trouble. Okay, the top, as all of you know, is an aluminum frame. Then there is a tempered glass and an encapsulant with a polymer encapsulant, which is again transparent but non-conductive in terms of electricity. Then a solar cell, which is a silicon wafer. We'll see how the silicon wafer is. Then again, one more insulating layer. When I say insulating, it is not a thermal insulation, it is an electrical insulation. And there is a strong backsheet and a junction box where the power is taken. So look at silicon wafer. It is the same silicon wafer as we use it in for chip making, what runs in our computer, etc. And we have multiple grades or types of silicon cells which is used, either monocrystalline, which has a high efficiency and high cost, of course, cast monosilicon cells, which is high efficient but slightly lower cost, but polycrystalline silicon, which has a lower efficiency and obviously a lower cost. So this is our one part. Then it can also be divided into different kind of ways in which we look at. That is one full module, what power it generates, because that is required for me to find out how the fault is when I am even looking at the voltage characteristics, the current taken through, the junction temperature, all that. When I am looking at, I need to know these specifications. And if you're looking at the efficiency wise, some of the standard information which I have picked up from standard white papers or websites wherein it is mentioned, because there are a lot of information available on what is the efficiency and what voltage range it works, and also what is the maximum power. Quite often when we go to a solar farm and they say it's not working well. So, but when it is not working well, it could be either the problem with the installation or few other reasons. So we need to be clear whether are we looking at the fault of the installation or are we looking at the fault in the solar panel. So irradiance, that is watts per meter square, that intensity, or is it getting shaded, or panel orientation, did anybody change the panel orientation, or is it wrongly selected, the temperature, the operating temperature, and when it is powered, what is the temperature which it gives, the location, latitude, where it is, the time of the year, and the dust and dirt. We saw that the last part was one of the major culprit in many locations when we went and did the inspection. So of 4 years together, we have been improving, or the world has been improving on the production of modules, solar modules. Now we are expecting by 2021 we will be getting a single panel which can provide you 600 watt. Now presently you can get up to 500 plus watt for one. But that is a bit costly. What is commonly available could be 300 to 400 range. The solar panels size and shape, which I have mentioned, this is also important when you are looking at the electrical part of fault detection. If I'm looking at the electrical fault, our electrical parameters for fault detection, the way in which it has been organized, the cell has been put together, is very important. 60 cell panel, 72 cell panel, or as it improves, how we need to look at the fault. Okay, size is also important. Plus, how many half cells are involved in each of the cell, each of the panel is also very important when we are looking at the fault. The basic building block of this PV cell is also need to be understood well when you are attempting to find fault or detect fault in a solar cell. So the one which we are going to get in a short while from now, maybe the beginning of 2020, end of 2020 will be 210 by 210, which obviously will give you around 600 watts. So what is available in the market presently is 156 square or 166 square. So from the cell, let us just deep down to find out the type of cell which we are using. There are two types. One is N-type silicon base and P-type silicon base. You don't need to worry too much about it, but at least the person who is trying to identify the fault should have some basic understanding how this PV cell is made, so that you can identify why is it working wrongly or doing wrong things. So N-type cell construction is little expensive because of the boron diffusion process, which is a slightly high temperature process. Where to add the thin P-type along with an N-type, you need to add a thin P-type emitter layer. So that is one, and it has one advantage, lower degradation over time, and it is the advantage is it won't go bad with time as easily as the P-type. P-type is obviously is less efficient but easy to construct and less expensive, because of the usage of a P-type cell is used with the phosphorus diffusion process for that thin layer. So that's why it is a low temperature, I mean slightly lower temperature and easier process than the N-type. So that's why it is less costlier, but efficiency wise also it is slightly on the lower side. Now we look at some of the faults. So now what we did is we looked at the entire solar farm, then came down to the PV cells, and then we looked at how the PV cell is made and the components and what is the present size and shape and power and voltage, etc. Then we also looked at what we are going to get within short span by 2020. So when we are looking at fault, what I can just look around and see is one, and what I can dictate after some time is another. So we look at the fault in these three different areas. infant fault when you are installed, and during that installation and commissioning, within a short period, if there are something which is coming up, it is called LID. Normally 0.5 to 5% of faults comes in this region. This is the infant mortality and infant failure, light induced degradation. So if your cells are getting faded out within quickly, then it is called infant mortality or infant failure, which is light induced degradation. And that could be also because of the manufacturing defects or construction defects or assembly defects, etc. Then comes PID. It is not the same PID as what we heard in your control system. It is potential induced degradation. Potential induced degradation, wherein the diode failure, cell interconnecting breakage, and all that comes under that. It's a mid-life failure. The component failure it could be, or the connection failure, and including the way in which it has been connected, and all that comes under this PID category, which is a mid-range or mid-life failure. Then after some time, until this failure, normally the warranty will be there. Once the warranty is over, you can identify the wear out failure will start. Delamination, maybe EVA decolorization, decoloring, crack, and cell isolation, and things of that kind. And there also could be a corrosion or cell interconnect corrosion or the joint corrosion, etc. can come. So this is how we are looking at the fault, when it comes, what are the faults it comes, and how we need to look at. So let us just see the kind of faults. I'm sure some of you who are working on solar PV modules might have seen this, because I know it is a general crowd of 40 plus people. So I thought I will just mention the kind of things which you can see if you next time when you get a chance to go and inspect a solar PV quite closely. The snail tails, that is the first figure. Those who are on the mobile, you may not be able to see it clearly, but if you are on the laptop, please keep this as a wider area. So you should be able to see the snail tails, hot spots. You can see the hot spots here. Then the black sheet chalking. Then the delamination of EVA, that is the part which is separating the glass, toughened glass, and the wafer or the PV cell. The insulating part, if it is getting delaminated, that is one. And browning of the EVA, micro delamination, small, very small delamination. And then you can also see the back sheet puncture. This is more a physical damage. While installing or when keeping things together, it can even do this. Arc deposition on the cell. Then look at the melting of JV junction box. Either an excess heat in the system, or it could be even otherwise a poor, less UV protected junction box. If you are using the wires you are using, that can also get affected. The connector failure, we have been seeing this connector failure quite often because the poor workmanship, it is essentially comes from the poor workmanship. And frame misfit. Frame misfit is also most of the time coming from the poor workmanship. Junction box adhesion. Junction box is normally kept on the back side of the PV panel, and that also comes down and the looseness can create, and the temperature at the junction can increase because of the loose contact or contact resistance, etc. So corrosion on interconnection. Many such this. I have just listed all the faults which we normally look at. Potential induced degradation is something which is quite common in many of the PVs, especially if we are not looking at a PV of an ISO 9000 standard or ISO certified kind of a PV, then the potential induced degradation is something which is quite common. Of course, the soldering defects, then the hail impacts, some external particle coming and hitting and such things, corrosion of finger brushes there, the back sheet delamination, the backside, because all this has an effect on the entire cell itself. Then also the cell cracking. So I've just listed here quite few faults. Now, out of this, we'll just see few of this and how we do the inspection. So that is the intention for the day. Maybe 45 minutes, we'll just look at how we are looking at these faults and how we can identify. So when you're looking at the solar farm fault detection method, the first one is, I know all of you are standing around, assume that you're all there virtually. So you're all standing around a solar PV farm and looking around. The visual inspection is the first one. Then if you cannot go to the place and do a visual inspection, you can arrange photography either by a fixed camera or using an aerial photo shoot or a video shoot. That is the first mode of inspection in most of the cases. Then comes, nowadays some of the panels comes with a smart sensor, IoT enabled sensors, slightly costly, so that each cell V and I characteristics and with respect to time can be easily monitored and transferred to a control system. Electrical parameter measurement. If it becomes very costly to check at each cell, at least one panel can be tested. One panel, the one frame is called one panel, can be tested and looked at. Suppose in a series, if one panel is not doing well, we can also do an automatic rerouting. So you can also do such things. You can have control elements like the relays where it can be reconnected or connection can be reoriented using appropriate methods. Then comes the thermal imaging, which is either handheld or drone based. So today we are just going to look at few specific things about thermal imaging, both handheld and drone based. And the story behind how did we reach there is also probably will be mentioned in the talk. Normal operation, if you are looking at the operation and maintenance of any of this, you will have PM activity of electrical equipment, regular module cleaning. This is what I mentioned by dirt and dust. Then the connection, corrective maintenance, wherever you need to do the corrective maintenance. This is the operation and maintenance part of a PV farm. And if your cells are already equipped with smart monitoring systems, we can do a remote monitoring. Usually it will be the company which installs the system will have all the data pushed to the cloud and they will do an analysis. One of the installation in our neighboring MRPL have their own team which is monitoring this. Whereas in our case and NITK as well as NMPT, which we do some work, are monitored by centrally. So now we are looking at, I can do an visual inspection. I can go around and find what is going wrong or where it is going wrong. It's very time consuming and you need to risk yourself to go to the rooftop or place where you need to do the inspection, or the people have to do that. Otherwise, we can take photography. That was the next method which we suggested. Or you can either have a permanent photography setup or you can have a drone going around and taking photography. The third method is you can do a thermal inspection. So thermographic inspection of a photovoltaic installation. The picture shows how the temperature gradient is changing on each. But quite often, this is a misunderstood thing. If you look at here, whatever I see in the front has a higher temperature, whereas what is far away is having a much lower temperature. It is not really true. So the difficulty here is the tool is common and many have the tool, but quite often the basic understanding of how to use the tool is almost forgotten. So we'll just look at such basic things today so that in case you get a chance to do such operations, or if you are trying to do a research or guide a research student on this area, you should get an idea about where you should focus if you are looking at this kind of problem statement. We have learned it with in a hard way. When we started working on it, we came to know that, okay, why we are not getting the correct results. Then we started going around and looking for information. If you take a full panel, which is mounted on a roof with a thermal camera, pictures like this can come. But this itself is not sufficient to make any conclusion. We need much more information to decide whether it is working fine or not. First part is as a quick analysis. quite often we also have a handheld thermal camera from Testo. We go around and just look at the thermal imaging as one part. This is if they say, you know, this part there is a problem, here we are not getting, or we have an issue, it can be done. But it cannot be done for a farm, which I have shown you, something like a 6 megawatt plant, which is there in the MRPL, or maybe 5 megawatt plant, which is there in NMBT. So there, we need to do thermal imaging with much more deeper understanding. Just taking a picture alone will not help us. We need to see what really is heating up. If you look at the second picture, where I am moving the cursor, you should be able to see my cursor moving slowly. There, you can see it is the connector is what is quite hot there. Whereas when I come here, it is cell heating abnormally is observed. One cell which is heating abnormally is observed. So if you look at this picture where I have moved the cursor, a faulty solar cell, that itself is putting an high resistance at whatever voltage and current which is passing through that is in fact getting dissipated there itself. Or it is not really producing anything, it is acting as a resistance across. And this could be another way of looking at it. You can see within the panel how we can look at, and here in these places you can see, hope you are able to see my cursor which I am moving. You can see how the heat source or heat, the temperature variations which you can predict. So when a full panel when you take, you may have to zoom in a place and try understand what it is. So and then superimpose over the actual image and see where did you take the image and what really is the matter and which cell need to be looked at, either to be disconnected or to be replaced. Then comes the battery connection. I hope you are able to see my PPT. Something really happened.
Yes, sir, it's visible.
Visible, but it is where I have just started. I need to go back to the place where we were. Yeah, I'm sorry about it because it was, I think I touched on the screen, which was again a touch screen. So that created the issue. Here we were.
Yes, sir. Yes.
So, I'm sorry. So we said we need a deeper understanding about, even if you have a thermal imager with you, and if you just take an image and say that, okay, I can do the consultancy or I can do the analysis, it's going to be quite tough. Because our experience is we had to put a lot of effort to understand each of this. And I'm going to give you only a glimpse of it because it itself is a long process. I just mentioned this, how do we superimpose on an existing this. And after looking at your solar panel, especially for smaller installations, there could be battery. And you also may have to scan the battery, whether it is a problem with the battery, whether battery reheating is happening, etc. Or the panel inspection, solar panel inspection, that is the first, then the battery inspection. Now, quite advanced technologies are available. We can even have the frames. I mean, you can take a video and see how things are working. Suppose if you have a really huge farm where megawatts of power are connected and directly connected to the grid, you can see the image there on the computer, which is put. It is the contact and connectors, which is temperature differences are shown. Now, we'll tell you how we did some of this work. We had, we did not look at thermal imaging as a first task. We were fascinated about the drone to start with. And Dr. Prithviraj was working with me at the Center for System Design. Is an very experienced drone pilot and had at least now presently more than 12 to 13 years of flying experience. So we were doing many kind of work in drone, and we were not happy with just taking photos. Then we started looking at how do I use this photo for something else. We started image processing the photos taken and started looking at it in different way. So we were initially looking at, can I just find out from RGB the normal photograph itself, can something come? Then by then this thermal imaging technology had improved. FLIR had come out with small things which can be cost effectively used. So then we started looking at thermal imaging, and that too on drone. Then after that, we also started looking at this as an activity where I should be able to specifically say very precisely which cell. So then we use the GPS system and the facility available in drone, as well as some of the commercial software, to pinpoint where exactly the issue is. We can make a mission path can be planned, and such inspection could be done. So when we started doing this, we realized we have not understood how this thermal imaging need to be done in case of a solar panel. And that is quite different from other thermal imaging, because we have been doing thermal imaging for rotating equipments or stationary equipments and bearings and things of that kind. That we had much easier way. But when we came to solar panels, we saw that we need to relearn quite few things. So thermal imaging, we were thinking in the early morning we can take a thermal image, because that's a time which drone flying is much easier, because we normally try early morning flights so that the wind and it is more comfortable. So but later we understood those images which we took were not sufficient. When we read the theory again and again, we understood thermal imaging need to be done at a solar radiance, that is the solar radiation of 50 watts per meter or better or higher. In fact, present day literature suggests 700 watt per meter square is an advisable thing. Or if you want to do it, if you cannot do it, you may have to have such a flashlight to be flashed to give such a irradiance which can be measured, and then take the thermograph. So this solar irradiation description, it's an instantaneous power. It can be measured, and the camera, when you are using, needs this kind of an approach. Otherwise, what you are going to take is not an operational one. This is one of the learning which we had. Then, quite often we come across errors in thermal imaging. One of the thing is, if you remember, we had a very shining aluminum piece which is as free. So whatever light getting reflected on that, that also comes as one image. So there will be a zero setting which is normally done. We saw that this is troubling a lot. Then we saw that it is the not the normal thermal camera which we need. We need a thermal camera with digital detail enhancement. Now presently most of the high-end camera comes with the DTE, which is called digital detail enhancement. It will be able to identify, is it a reflected image of a metal surface which is at a low temperature, but because of the shining nature it is reflecting the rays, the IR rays, or is it the actual temperature itself? So that was one case. The second was, most of us thought we should go to the top directly perpendicular, that is called the zero angle, and take the reading. But after reading and understanding the reflection and other issues which come through from the glass, the toughened glass which you have, which also have an emissivity of 0.85 to 0.9, and the wave band is 8 to 14 micrometer. So the problem was, if I take a perpendicular reading, it was giving wrong results. So later, through the documentation and the literature, it is understood a better view angle is 5 to 60 degree. And too low is also not a. Remember, the vertical is called 0. From the vertical 0, I am moving at an angle 5, at a slight angle. And in a drone, it is easy to do this because the camera itself can be tilted. Even if you are just on the top, camera can be tilted slowly, and you can even set that to the horizontal, what angle you need to look at, etc. So this was the second thing. So if you look at the image which I have put here, I'm just moving the cursor there. You can see at some locations I have a higher temperature, other places not. So it came essentially from the viewing angle difference. So we need to make sure that such measurements are done with very good precision, and making sure that we know what we are doing rather than we know how to use the tool. Just running the tool alone will not give you the actual result. So this is the viewing angle which I have mentioned. If you look at the picture there, this is the vertical line. From here, we need to either on one side, we need to make sure it is giving you appropriate angle in order to get good results. And again, when the budget is really an issue, we go for a low resolution camera. But later we understood if you want to do a good thermal imaging, especially for solar PVs, then we need 320 by 240 pixels, or better pixel is always better, but you are going to pay through your nose if you want high resolution cameras. Okay, so FLIR P660 is the image which is given here on this. So let us just look at what do you see in a thermal image. The warm area will show up clearly in thermal image. I mean, this is what our general understanding. Depending upon the shape, location, these hotspots and area can indicate several different faults. Again, here it is more in subject expertise which will be able to identify what fault it is. It is not something very straightforward. If I see this is the answer. No. And it's much more complex than just looking at, can I just say that, okay, 1 degree extra or 10 degree extra, it means this is the meaning. It is not that easy as such. If an entire module is warmer, that might be indicating an interconnection problem. Or some of the things which I'm listing it here. Shadows and cracks in a cell shows up as hotspots. Polygon patches in the thermal hotspots or polygon patches in the thermal image. The temperature rise of a cell or a part of the cell indicate a defective cell or a shadowing. Then the thermal image obtained under load and no load and short-circuited condition should also be compared. This was another issue which one stretch, if you take the reading and come, is going to be one. We may have to disconnect and see what happens. We have to connect it to the load, get the maximum for that given radiation, irradiation, and see once. And sometimes we may have to do a short circuiting and see what is happening. So that is also a learning when you start doing this. A comparison of thermal image in the front as well as rear of the module can also give valuable input. But this problem is those are in the rooftop. We found it is pretty difficult because it will be kept on the roof. The underground, the bottom portion thermal imaging is going to be difficult because even if you have, say, for example, 1 feet gap, you cannot keep a camera below and click a picture. Whereas we need slightly higher distance. Typical measurement errors are too shallow viewing angle. So if you are making a viewing angle too shallow, when I say too shallow, it is from vertical, I'm taking it almost horizontal and trying to see. So nobody do an horizontal measurement, horizontal thermal imaging, but especially in a drone, if you have taken it for a far away place, then the angle comes quite different. So that is one issue which we saw. Change in solar irradiance over time, especially for a large farm. We take it in slots. So morning we might have done one flying, then take the reading. Maybe after breakfast or tea, we take another reading, and afternoon we take a reading, and evening we take another reading. Because each time flight, we can do 10 to 15 minutes of flying, only possible in case of normal drones. And that too, we may not risk it to take it to something like 75% of the battery of the drone. That means generally we keep it at 60% of the battery we consume, and then we abort the mission or plan the mission in such a way that take that much of reading and come back. Then it need to be charged, then we take the reading. See, the sun is not going to be in the same place, and irradiation could be different, irradiance could be different. That can create an issue, and especially for very, very large farms. Then the reflection, sun, cloud. Cloud was troubling us, especially in our South Indian conditions. Quite often the big clouds can come and really spoil your entire reading. Partial shadowing, this is what something which we saw, especially sometimes there can be a partial shadowing which can come, either a building or a structure. Only at some times this can come because depending upon where the sun is. So that also creates a lot of issues. These are typical measurement issues which we saw in the practice. So this alone is not that sufficient. So assume that now I have understood basically how a solar farm is, and I also got to know how I can take the reading. Then if you want to do a complete analysis, it is always better this is done over a period of time. So we need support from the data analytics, because now it is a time data is the new oil. So all that information which is collected for a large farm, because I'm not talking about a house where 1 kilowatt solar plant is put or a 2 kilowatt solar plant is put. So this we are talking about, say, 5 megawatt and above, where you are able to invest on the smart monitoring system and get the data, put it in the cloud, do all the analysis to make sure that you understand how the system have been behaving. Presently, we have a lot of approaches for monitoring, and even multiple sites can be monitored, and it's all cloud. Normally, the data goes to the cloud and informations are processed in the cloud itself. So this is the place where we started with. Now we said the solar farm, and I took you through a set of things which we have done. And most of that, what I have shown is our understanding rather than textbook information. Of course, textbook helped us in getting this information. What I would like you to do is probably just after the talk, you can go to Center for System Design's YouTube channel. There is one work which we did for frog, the guardian of wildlife, and another one called Drishti, direct recording of standalone thermal imager. So these two pictures give you an idea why did we get into this. This is really the story starting point. Somebody from IASC, a team who is working on frogs, came to us asking, without disturbing the frog, we wanted to study its behavior. They remember they are from biology background or zoology background. They are not engineers. They said they are doing a PhD or work on this. They want to do it. And they said the frog is not very comfortable with the light. It is a bit of a photophobic, or in a night, if the behavior want to be studied, it's not good to put a flashlight on the animal or in the creature and do it. So this was one thing which we tried out, and you can see what we did in using thermogram on frog. Then we were looking at, is it possible to detect a person who is drowning in the night using thermal imaging? And we wanted to make it as an open source, and that's what we gave in this Drishti. Because when I play that in YouTube here, because all these online webinar or conference systems will have very low frame rate. If you look at the Team and Zoom, etc., it has, I think, 3 frames per second is whatever I show you here, 3 frames per second will be shown to you. That means you're going to get the video which I am playing in my computer as broken. So that's why I'm not playing it here. Please visit this Center for System Design YouTube channel. You should be able to Google it out, Center for System Design, and in Google, and look at thermogram, the frog. A lot of videos will be there. In that, the technical videos you can look at and see how we have looked at things in this way. And we also did a lot of consultancy work, not just in Karnataka, elsewhere. Some of the places where I can mention the name I am mentioning and giving you very brief view of what we did. It was IIT Jammu. We have done using drones. We have done quite a few things, and we are managing the construction progress, looking at the progress and such management we were looking at. We have taken it up as a consultancy work. And this all work done through drones, and an NITK team led by Dr. Prithviraj helped us in getting these things done using drone. This was another work which I said you can make out by looking at the location where it is. And this is a tough task because it's a large farm. And if you want to identify one by one, it's going to be an Herculean task. And as I said, if you want the viewing angle to be put appropriately, you need to take the drone slightly away. And it gives you an angle in such a way that what you see just below is almost perpendicular or plus or minus 6 degrees. But as you go far away, it's going to be widening. So this is one work which we did in Mangalore. Another view of that. And this is a closer view, which I started with. So this thermal imaging has also helped us in looking at different things. Our SI Formula One students were trying to see why it is not getting sufficient power. They were looking at all the possibilities. Then I'm sure that mechanical engineers will make out now what is that the reason is. You look at this engine, all the exhaust pipes. You can see 4 exhaust pipes here. And look at this. When thermal image was taken, one cylinder was not getting fired at all. That was the reason. And we also did a lot of such measurements, imaging, and it also was more to do with our learning process for understanding how thermal images can be used. Use it for many of the biology applications. Rotten free-tailed bat, which was an endangered species in Western Ghats in Kudapur Taluk, Belgaum district. We have gone and did, of course, it was a long trek. We have put a video on the same rotten free-tailed bat video, thermography video in the same website, YouTube channel. You can have a look at it. I'm not playing this video. This is that video actually. And this is the open source solution, which after working on some time on this, we understood we don't need to really pay this much of a cost when items are available for us to integrate. So direct recording of standalone thermal imager was one. Even this video you should be able to, the video documentation you should be able to see on our YouTube channel. I'll skip this video. I will not play the video. To give you some simple specifications, this is how we started with. It was an open source, extremely flexible, light and compact, and made at NITK CSD, and that's what we wanted. We wanted our students to work on multidisciplinary projects. Those who are listening, those who are, most of you will be teachers or looking for academics as an option. So convince your students to work on multidisciplinary projects. And if you can get some 2 or 3 faculty members from different domains to come together, it's easy to make this kind of activity. There should be someone who will help you to put these electronics together. There should be a person who know what they are doing in terms of thermal imaging, a civil engineer who can just help you to look at how the surveying done, all that put together, and maybe a mechanical engineer, you can use a laser cutter and make a case or a 3D print a case and put things together. An electronics person who can integrate all the sensors and make it as a final product. So with this, I'm just coming to my last portion. I would like to thank my PhD scholar who helped me to get some of the pictures and content for this, and obviously Dr. Prithviraj Umesh, who is an associate faculty at Center for System Design and an assistant professor in Department of Water Resources and Ocean Engineering, the new name of Applied Mechanics. Most of the photos and pictures, aerial shoots and videos, which we have either put here or shown in our YouTube, are taken by Dr. Prithviraj and his team. So with that, I'm concluding my talk, and we'll just have a question and answer session wherein if I know some answers, we should be able to share. Otherwise, we'll see how we can get the answers together. With that, I'm concluding my talk. I'll just reiterate what I did. I just started with the basics of solar farm, and then we went ahead with each of the components. So each components, the understanding was required. Then only we can look at the fault. Then I took up other few faults which can be used, and I just again focused on looking at only the thermal imaging, because within a time of 1 hour, and that too a diverse crowd, I don't think giving an advanced topics is worth a while, and that too it is an online session. So that is why I just put this in this way, so that we get basics of solar power plant, then solar cell, few fault. I have listed almost all the faults, in fact, of the solar plant. Then 1 or 2 methods how to look at it, and the story behind how did we get in. And these are not the textbook information which we have given. There's more to do with the what when we went to the field, how it was and what we understood from that is what I have given. So thank you for that opportunity. I'm seeing some chat where some questions are there. I'll either take up the question from the chat or one of you can coordinate and ask me the question.
We'll ask you the questions, sir.
Yeah,
Okay,
because
so
the
it
crowd
was
is less.
really informative session, sir. So more of practical knowledge we gained from this one. So especially whatever the problems that is actually there in a solar panel, solar, everything we got to know. So there are some of few questions in the chat box. I will read it one by one. So first question is being from Mandar Suman. So he asked the question that what are the main characteristics of storage devices like batteries of PV systems?
Okay. Okay. I hope they are not looking at the electrical part. When I look at the characteristics, I'm looking at what is the voltage input which I am giving that depend on my inverter. That is, this is a DC voltage. Even that DC voltage need to be regulated before giving to your DC storage. And what kind of current I am looking at? Is it a 40 ampere hour or 140 ampere hour, or is it in a bank? If I have a large power to be taken, I better go for a higher voltage. So a higher voltage reduces the current which is being carried. So V into I is your W. I mean, all of us are mechanical or even electrical are there. I'll accordingly, can I get a feel of whether it is electrical and mechanical crowd or only mechanical crowd?
Sir, it is combined, sir. Electrical, mechanical, and even civil engineering branches also there, sir. Structural, who is specialized in structural also.
Okay, I know, because people should not shout at me and go. If I focus more on, see now when you are looking at the storage, it depends upon, it is a part of your solar panel power plant design. It's the system design. So I will look at what is the power I require and how I can get that power, how much area I have. Depending on that, we decide on what characteristics we need. Suppose I have a I'll put it as 140 Ah battery which I am using, and either it is a 20C or 30C depending upon the current carrying capacity of the battery, and it decides how I put things together. And now it is also seen lithium ion batteries and other high-end storage devices are being used, especially for smaller devices. Smaller devices, we do have that. We have such storage facility also. I'm not sure whether I have answered his question completely, because I'm not sure what exactly he looked at by characteristics. Is it V and I characteristics or power, delivery, etc.? This is the present answer which I could give.
Okay, sir. So Mandar Sumat, I hope your question has been answered. So he has another question actually. So what are the positive impacts of putting floating solar panels over a water body like the ocean or irrigation dams, rivers, and canals?
One of the good experiments, that's a good question, because one of the good experiments done is it in MRPL. MRPL has one of the largest floating, because if you remember, MRPL has need and we do have photos of many of these things, but unfortunately we cannot put it in the public domain, and that too it is a recording session is getting recorded. So we have such restrictions because most of the work are done for some client. Some of the places I cannot even reveal the client name. Okay, these things, because it is nearby, I'm just telling you, MRPL has a floating power plant. The difficulty there is how the ecosystem below the power plant works. So you also need the water, the ecosystem inside the water to be flourishing. So there are some ecological issues which they have identified, but a storage tank, it's not an issue. But if you have a huge lake and if you create entire surface, you feel that that surface is not required and it is free for you. And if you cover, you are actually imbalancing the ecology there, because you don't get sunlight directly below the water, and which is required for that ecosystem to sustain. This is one thing which we have understood. But what we suggested in one or two places is we can have floating, and that floating can keep moving some locations in, say, for every week or every day. It can be just towed literally here and there, so that the ecosystem there is still maintained and we are able to make use of the area which is available.
Okay, thank
I
you,
hope
sir.
a person might have seen some of the floating power plants, because many are there now.
So we will go to next question now. I think
Yeah.
Mandar. Okay, so we'll go to next question. So this question is from Natarajan V. How to replace the defect solar cell in a solar panel?
Oh my God. Unfortunately, I don't have an idea, but I have seen people doing it, but I cannot give you with that kind of a comfort. So what we saw, because we work with people who have been doing it, they just replace the entire panel and then they take it and get back with the repair. I don't think within a panel cell can be replaced on the site. This is my present understanding. I have not tried it out. So wherever we have gone, the maintenance, when we do this inspection, the people who are operation and management group who will be with us will identify which panel need to be replaced. So usually they will have almost 20% additional panel ready with them. And when they see that something is almost dead, above 40% is gone, then they replace the entire panel and give it for repair. I'm not sure repair to what extent it will get done, but they take it for repair. That much I know. Because this soldering in between changing, I could not see anybody doing it. At least that much. I have not read anything about that the repair, but I did not see people doing it.
Okay, so we will move on to next question. So this question is from Dr. Lokesh. So how we can automate the fault diagnosis work in solar farms using thermal imaging?
Very good, sir. I'm happy that such a question came. In fact, if you just look at research papers, now anything and everything is AI and ML. I mean, even if you breathe twice, they say I will have an AI or an ML engine working behind. So there are a lot of research publications already available on using thermal imaging and artificial intelligence to find out how it can be automated. To what extent it could be implemented in farms, solar farms, at least from my understanding, we haven't seen a system where it is implemented completely, but there are a few organizations, one from France, one from, I think, Switzerland, have a very hefty software, which is very costly. They allow us to upload that image to them, and they will give you some analysis. And buying that software is very costly, so they give you monthly activity. You can upload and give things, and such agreements are there. That is one thing which I have seen. Some of the bigger farms are now getting automated, but it is done by the operation management team who normally do the installation. This is my present understanding, sir. Okay, sir.
I am sorry to
Yeah, go ahead,
interrupt you.
sir.
I'm
Yeah.
any feature diagnosis, which feature we can take if we go for a thermal imaging? Any specific?
No, it's the temperature. What it gives is only the temperature and the location and the size of the temperature patch. See, we have only three informations. One is the patch size, the temperature patch size. That is how much area that the higher temperature is there. What is the shape and size of it, and neighboring locations. Where is it? Is it on the junction box? Is it on the top portion, etc. So temperature, the location, shape and size is what we have as such. Temperature gradient also we know how did it reach there, and these are the information available as a parameter to process.
Sir, just to go in depth on that, I could able to see some red colors in the presentation in your slide.
Yeah.
Can you diagnose the amount of fault in that? Is it possible? Anything like that with your research work?
No, if we can identify what is the temperature rise there. Okay. From temperature rise can come from multiple reasons. That's a place where we are literally struggling. It is not one reason that can give you a higher temperature. Even if there is a contact resistance increase in the line, the solder, it can give a higher temperature. Or if one of the cell is faulty, it behaves like a resistance. Instead of generating current, it will pass the current, but it will act as a resistance. So I square R loss will come there. So whatever heat is generated is your I square RT. So these are the things, because I did not say it is something straightforward. You say that 1 kg force is applied, it will go by 1 centimeter. Hence, this is, it is not a linear relations of that kind. At least that is our present understanding. If people have done, because we haven't went in very depth, we have taken few of this and tried to understand. We are still in LKG. I mean, we believe we are still learning into the first alphabets of looking at these things. So I'm not confident to give you a straightforward, complete answer on that, sir.
Thank you, sir. Thank you, sir.
Hello, sir.
Yeah, please go
We
ahead.
have another question from D. Devarasipappa. So here's a
Okay.
question that can solar panel be recycled? Like faulty solar panels, so whatever they had been replaced, so
Yeah.
the be recycled or not?
I have read that it can be recycled, but my present understanding on that is limited, because I read that it can be recycled, the wafer can be, but one more comment which I saw the same place is, it is much more costlier than, suppose if the country has a restriction on just throwing the item, because some of the countries, if you want to buy a TV, you need to process the old TV, and processing and giving the old TVs half of the cost of a new TV itself. So they need to do that, then only they are allowed to buy the new item, because electronic waste processing is a costly activity. In such places, they do it. And I read some of the Chinese activity there, because they have a huge installations, they have done something, but I'm not sure to what extent they are doing.
Okay, sir. Thank you, sir. So I have my own one question. So
Yeah,
that
please go ahead.
drone thermal imaging is there, right? So
Hmm.
that how efficient is it? Because there are many problems while using drones also.
Hmm.
For example, while taking the images, so sometimes the image thermal images may not be clear, or sometimes what happens to the drone's own shadow, so it may also affect the thermal imaging. So
Good.
how everything can be avoided, sir?
Yeah, this is an issue which comes in when we are taking it in the noon time. The shadow will come in the place where you are trying to see down. Whereas we make sure that the angle is, we are able to, because the camera can be tilted on the drone. So if camera, the drone shadow will be depending upon where the sun is, you can identify. You tilt it in such a way that you are not too flat, that is 0 to 50-degree inclination with vertical is the way in which we put. It is by experience it is possible. You need to also look at whether it is Dakshinayana, Uttarayana, whether you are in what cycle, and whether you are going in the before noon or afternoon. Those, and we do the mission planning accordingly. The mission planning is done in such a way that these shadows are not troubling. And we also saw it is not that straightforward. I mean, many locations it has to be done multiple times. What we thought we will get a good picture, once we did not, then we need to redo. All that is the way. Or some professional consultant, the people who have been doing only this, may be able to give a much better or deeper understanding on that. Probably they will not give understanding to us, because that is their bread and butter here. Because we being teachers, we will be able to share what we have understood.
Yes, thank you, sir. Because I didn't know that even using drone, the thermal imaging will be done. So, Lokesh,
It's
sir.
a major activity, Anudeep, now, because at least even in India, there are many people who are doing. Of course, we are doing it in quite heavily. We also do a lot of activity with the drone with the lidar, mapping and survey, and that too we look at very difficult locations, like very remote locations, Uttarakhand. I mean,
Yes,
me and Prithviraj is good at trekking, so we club all this together. So it will be a consultancy work, it will be a trek, it will be outing for us. All that put together is what we do. We carry our drone quite often. Even in Himalayan trek, when we went, we carried, and we had those who are interested in such things can look at that YouTube video. We do have plenty of things which we have put it in YouTube, because it is in online. It is very difficult to show you a movie as such, because these movies are actually high definition movies. I mean, done fairly professional. Uh, so please look at it if you are interested in those kind of domains. Yeah,
sure,
go ahead,
sir.
Anand.
Sure, sir. I think Lokesh sir wants to speak something.
Sir, Professor, can I ask you some more question, or am I, we are taking more time, sir?
No. I think our time is up to 12:30. No, you have still time.
Okay, okay. Because getting your time is difficult. Okay. The question is, can we use the current monitoring or any other technique for the root cause analysis, sir?
Yeah, people are using current current and voltage monitoring, because this every cell can be embedded with a smart sensor. The advantage is, if you put a smart sensor, each cell we will be able to find out what is the radiation, then how much is the current and voltage it produces. I mean the combinations. Then when there is a load, how the fluctuations comes. So such things people have done, and they also did some algorithms to identify for a large area. When you have large area and same kind of cells, they could identify which cell is really doing badly. Research papers I have seen, but we did not start with that, because for that you need really a good support from a large farm, and they should be willing to put the IoT sensors on each of this. Slightly costly affair as of now.
Thank you, Professor.
Okay, so I hope there is no more questions from participant side. Okay, so I think we have come to the end of this session. So I would like to express my gratitude to Dr. K.V. Gangadharan sir for accepting our invitation and sparing his valuable time in the knowledge sharing process. Sir, thank you on behalf of the department as well as the institute and the management side, sir. So we are happy that you
Thank
are
you.
here, and the talk was really inspiring. Okay, so it shared a lot of practical knowledge to us. So really, thank you very much. Thank you,
So
sir.
I hope I did not go too much deep and make people boring, because I was worried whether we will be getting into more research topic, and that's why essentially I avoided all the equations. Nothing I have mentioned math.
No, sir.
Hope it was.
Actually, it was more focusing on the practical issues itself. So that was
Yeah.
really interesting, to be honest.
Thank you. Thank you.
Thank you very much, sir. Thank you.
Fantastic, sir. More practical ideas we could able to get.
This is what we did. I mean, it is not something we read. So when we started doing, we do things and then understand what it is. That is our approach normally. So when we started doing, we found these difficulties, and then we saw that, okay, this is what can be the issue. Okay. Thank you, sir.